In this video, we're going to go over the KutaSoftware Infinite Algebra 2 free worksheet, Basic Polynomial Operations. I'll leave a link in the description below so you know how to access this free worksheet. Now, the first set of directions are to name each polynomial by degree and number of terms. So again, we're going to start by finding the degree and then the number of terms. Let's dive into number 1. For number 1, you can see that the highest degree in our polynomial is a 1 because we have x that's the same as x to a first. A degree of 1 is known as linear. So naming the polynomial by the degree, we know that this is a linear polynomial. But not only do we need to name it by the degree, we need to name it by the number of terms. And you can see there is one single term, therefore this is a linear monomial. Again, linear takes care of that degree of 1, and monomial means that our polynomial has only one single term. Let's move on to number 2. In number 2, what is our highest degree? That's how we name a polynomial. We pick out the highest degree. We have two separate exponents, one of 4 and one of 2. So since the 4 is greater than the 2, we're going to name this based on the 4th degree. Another name for the 4th degree is a quartic. So this is a quartic polynomial. So naming it by the degree, we just now need to figure out how many terms. And you can see here, we have one term and then we're subtracting a second term. A polynomial with two terms is known as a binomial. So this is a quartic binomial. Let's move on to number 3. As you can see in number 3, what's our degree? Well, we don't have any variables in here. All we have is a constant. Thus, the polynomial named by degree is known as a constant. But not only is it just a constant polynomial, we can see that there's one single term, so this is a constant monomial. Constant for the degree and monomial for the number of terms. A constant monomial. For number 4, the highest degree we have is this 6th, which there's not necessarily a special name for a degree of 6, so we're just going to call this a 6th degree polynomial. And how many terms does it have? 1, 2, 3, 4, 5. So it's a 6th degree polynomial with 5 terms. Just as we don't have a special name for the 6th degree, we also don't have a special name for 5 different terms. So we're going to just call this a 6th degree polynomial with 5 terms. There's not a special name for a 6th degree, and there's not a special name for a polynomial with 5 terms. Thus, we're going to leave this as a 6th degree polynomial with 5 terms. Let's move on to number 5. In number 5, our highest degree is a degree of 3. And with a degree of 3, we do have a special name for it. Think about it. A degree of 3 is something cubed. So this is a cubic polynomial. And how many terms does it have? 1, 2, 3, 4. We don't have a specific name for a polynomial with 4 terms, so we're going to call this a cubic polynomial with 4 terms. Let's move on to number 6. Number 6, our highest degree is 2. It's that x squared. But unlike before, where we have x cubed, then we had a cubic polynomial, when we have something squared, we know it to be a quadratic. So this is a quadratic polynomial with how many terms? 1, 2, 3 terms. And a polynomial with 3 terms has a special name. That's known as a trinomial. So we have monomial for one single term, binomial for 2 terms, and trinomial for 3 terms. So this is a quadratic trinomial. On to number 7. The degree is a degree of, well, we have the variable b, and b is the same as b to the first. So it's a degree of 1. And to a degree of 1, that's known as linear. So we have a linear polynomial with how many terms? One term, so that's a linear monomial. And lastly, for this set of directions, number 8. In number 8, our highest degree is that degree of 3, which we know to be cubic. And how many terms are there? 1, 2, 3 terms in this polynomial, so it's going to be a cubic trinomial. Now on to number 9, the last question for this set of directions. It's a critical thinking question. It asks, why is it impossible to have a linear trinomial with one variable? So let's think about what linear means. Linear is a degree of what? Is a degree of 1. So if we had, let's say, 2x, that's a linear monomial. But we want to see if we can make a linear trinomial. And it says it's impossible, so let's just give it a go. Well, if we have a linear polynomial, we know that we can't have a higher degree than a degree of 1. So we can only go to lower degrees. So the next potential option is a degree of, well, 0, which would just be a constant. So let's say 2x plus 4. And there's no other term that we can write. We're assuming that our degrees are greater than or equal to 0, so they're in the positives, and we can't have another degree that's less than 1. Therefore, at most, we're going to have a linear binomial. We're never going to get to that linear trinomial. That is why it's impossible. So, writing this out, we're going to say that it could have at most those two terms that we talked about, a linear and a constant. Now for the fun part, let's move on to simplifying each expression. So in number 10, we're going to be simplifying these two binomials. And if you notice, they're both quartic binomials. They both have a degree of 4. But we're going to be able to combine these two binomials together. And we combine them, again, by like terms. So we combine those similar degrees together. Thus, we're going to combine 4m to the 4th with m to the 4th. And we're going to combine m squared with 5m squared. So 4m to the 4th plus m to the 4th. Well, if we have 4 of something and we're adding one more of that thing, we're going to have 5 of it. So that's 5m to the 4th. Now combining our m squared, we have a negative m squared since it's subtracted, and then we're adding a positive 5m squared to that. So that's going to be a total of a positive 4m squared. So this is going to be plus 4m squared. And there's no other thing we can do to simplify this down. So that's our solution, 5m to the 4th plus 4m squared. So in this case, we combined two binomials together through addition and got a binomial itself. That would not have been the case if we would have had, let's say, a degree of 3 here, because then this degree of 3 could not have been combined with the degree of 2, and it would have left us with a trinomial. But let's continue on to number 11. In number 11, we have two binomials that we're combining through subtraction. So we're going to need to pick out our like terms and combine. So our highest degree is x to the 4th, so I'm going to combine my x to the 4th with this 3x to the 4th. Notice that it's subtracted, therefore x to the 4th minus 3x to the 4th is going to result in a negative 2x to the 4th. Then I'm going to combine my 5x with my 4x. Again, we need to note that there's subtraction in between these two binomials. And since these parentheses are here, the subtraction is applied to all the terms within the binomial. So 5x minus the 4x, that's going to be a positive 1x, or simply x. So we have negative 2x to the 4th plus x as our solution for number 11. In number 12, we're going to be combining together two different trinomials. Let's start with our highest degree, finding all those like terms. Our highest degree in both trinomials is this degree of 3 here. There's no other degree of 3 in this other trinomial, therefore we're going to leave 7x cubed as is. Now we're going to look for our next highest degree, which is a degree of 2. We have a 3x squared and a 6x squared. Combined through addition, 3x squared plus 6x squared is going to be a positive 9x squared. Now, taking into account our next highest degree, that's a degree of 1, which occurs only in our second trinomial. So we're going to have plus a 5x. And then lastly, we can combine our constants together. Combining the constants, we have 5 and we have a negative 12. So 5 plus a negative 12 is going to result in a negative 7. So here's a case where we combined two trinomials together through addition, and those combinations gave us a cubic polynomial with 4 terms. Let's move on to number 13, the last problem on this page. And before doing this problem out, if you've been finding this video helpful, please let me know by clicking that thumbs up button down below. But anyway, let's keep moving. So looking at number 13, we're going to find that highest degree at the start, which occurs in our second trinomial, that 12x to the 5th, and it can't be combined with anything else. So we have a 12x to the 5th. Our next highest degree looks to be a degree of 3, and we have two separate terms with a degree of 3, so combining 8x cubed plus a negative 7x cubed, that's going to be a positive 1x cubed, so plus an x cubed. After that, looking for our next highest degree is a degree of 2, which occurs in both polynomials that we're combining, the 3x squared and the 6x squared, combined with addition, is going to be a 9x squared. And then lastly, we just have this constant that will add on to the end. So 12x to the 5th plus x cubed plus 9x squared plus 4 is our solution for number 13. For number 14, we have a binomial that we're adding to a trinomial and then subtracting another binomial. What we can do is combine the terms of similar degrees all together. And when we combine those terms, the degrees with the given variables in the terms have to be the same in order to be able to combine them. So starting with our highest combination, that's going to be our m to the 4th and our n squared. There's no other term with both an m to the 4th and n squared. There's a few m to the 4ths, but because they do not have the n squared as well, they cannot be combined together. Therefore, we're going to start with m to the 4th times n squared. So now that we have that taken care of, let's move on. Looking through this, we also have an m squared and an n cubed. There's no other term in here with both an m squared and an n cubed. Therefore, this term is also going to be in our final polynomial as is. But since we're subtracting a negative, it's the same as adding a positive, so I'm going to add 13m squared times n cubed. Next, we have a degree of 4 with m. So we have a 13m to the 4th, a negative 2m to the 4th, and a positive 5m to the 4th. So we're going to combine those together. This 13m to the 4th is added to this negative 2m to the 4th. And I'm going to call it a negative since it is subtracted within that polynomial. So 13 minus 2 is going to result in 11. So right now we have 11m to the 4th. And we're subtracting a positive 5m to the 4th. So subtracting 5m to the 4th from that 11m to the 4th is going to result in 6m to the 4th. So then we'll add a positive 6m to the 4th. And then lastly, we only have two more constants to take care of. That's our constant of 2 plus our other constant of a positive 2, which is going to be plus 4. So there we have it. M to the 4th times n squared plus 13m squared times n cubed plus 6m to the 4th plus 4. Now on to number 15. Again, let's start with those highest degree combinations. That's going to be m times n cubed. And if you notice, we have 1, 2, 3 separate terms through the combination of all our polynomials that have m times n cubed. So starting with negative 10m times n cubed, we're going to be subtracting a term that is subtracted. So subtracting a negative, that's the same as adding a positive 7 times mn cubed. So adding those together, we're currently at a negative 3 mn cubed. Negative 10 plus 7, negative 3. So negative 3 mn cubed, and then we're subtracting 6 mn cubed. So that's going to be a negative 9 mn cubed. So now that we've taken care of those terms, our next highest degree is within, and that's an n to the 4th. So we can see that we have n to the 4th here, here, and that's it. Two separate times. So negative 4 n to the 4th minus the negative 2 n to the 4th is negative 4 n to the 4th plus 2 n to the 4th, which is minus 2 n to the 4th. And then lastly, we can combine our n cubes together. So we have a negative 6n cubed, and we're subtracting a 5n cubed, but don't forget, wait, what was out in front of this polynomial? It was subtracted itself. So implying this, that's actually going to result in a positive 6n cubed. So 6n cubed minus 5n cubed is going to result in a positive n cubed. So plus n cubed. So just make a note to make sure that you're distributing that subtraction or those negatives throughout. If you need to, you could also start by rewriting this problem at the very start, getting rid of all the parentheses by distributing that negative through. So if I wanted to, I could have written negative 10 mn cubed minus 4n to the 4th minus negative, so plus 2n to the 4th, again, minus a negative, so plus 7 mn cubed, and again, minus a negative, so plus 6n cubed, and then we have minus 5n cubed minus that positive, so minus 6mn cubed. Combining all those together, here we had the negative 3, but with another negative 6, that was that negative 9. Here we have negative 4 plus 2, which was the negative 2, and 6 minus 5, which was that n cubed. So you could also write everything out. But that's our final solution for number 15. The last solution on that set of directions. But now we're going to move on to our next set of directions where it states to find each product. So we just did operations with addition and subtraction, combining those polynomials, and now we're going to be multiplying polynomials. So here we have number 16, multiplying two binomials. This should be fairly familiar by now. It's the distributive property, FOIL. First, outside, inside, last. We need to combine each term of one polynomial with the other. So each term of our first binomial with the terms of the other. So we're going to do 2n times n, then 2n times 2, then 3 times n, then 3 times 2, and we're going to combine each of those through addition or subtraction, depending on how the signs work out. So we have 2n times n first, which is 2n squared, and then we're going to multiply 2n times, I'm going to think of this as a negative 2. So 2n times negative 2 is a negative 4n, so I'm going to be subtracting 4n, and then 3 times n, I'm going to be adding 3n, and then 3 times negative 2, that's a negative 6, so subtracting 6. This all simplifies down though, since I can combine my 4n and 3n, combining those like terms because they have the same degree. So that's going to be 2n squared minus n minus 6. That's my solution for number 16. In number 17, again, we have two binomials that we're combining. So first, outside, inside, last. Combining first, we have 5v times 4v, which is 20v squared. Outside terms, 5v times 3 is going to be a plus 15v. Inside terms, negative 1 times 4v is a negative 4v. And then lastly, our last terms, negative 1 times 3 is going to be a negative 3. So subtracting 3. Now combining 15v with 4v, that 4 is subtracted, so that's going to combine together to give us 11v. So this simplifies down to 20v squared plus 11v minus 3. For number 18, we're still working with binomials. Multiplying binomials, we just have to boil it out. So the first term goes to both terms, and then the second term of our first binomial goes to both terms. So 2r times negative r is a negative 2r squared. 2r times negative 7 is a negative 14r. Negative 2 times negative r is a positive 2r. And then negative 2 times negative 7 is a positive 14. Combining negative 14r with a positive 2r, that's going to be a negative 12r. So this results in the polynomial negative 2r squared minus 12r plus 14. And that's our solution for number 18. In number 19, foiling this out, distributing my terms. 3x times 3x is 9x squared. 3x times negative 6 is minus 18x. 5 times 3x is plus 15x. And then 5 times negative 6 is minus 30. Again, you can see that every single term is multiplied together. My first term goes with both, and then my second term in my first binomial also goes with both. You could think of this in the opposite direction. This 3x, you can see, connects with both, and the 6 connects with both. However, continuing this, simplifying it down, we have 9x squared minus 3x minus 30. Since 18x is negative, and we're adding that to 15x. Moving on to number 20, and it's getting a little more fun because now we're dealing with trinomials. But remember, every single term must be combined together. So let's look at our first term of our first trinomial. We're going to take this negative 4x squared and combine it with every single term in that second polynomial. We have negative 4x squared times 4x squared, which is a negative 16x to the fourth. Then negative 4x squared times negative 6x, that's a positive 24x cubed, since we add those exponents together. If you're confused on how I got the x to the fourth or the x cubed, I'll leave a link in the description down below or over here in the cards linking you to a video that I've previously done where we worked with multiplication and exponents. Again, when we multiply terms together, we add those exponents. So 2 plus 2 became that 4, and 2 plus 1 became that 3. Continuing on, however, negative 4x squared times a negative 2 is going to be a positive 8x squared. Now, on to our next term in our trinomial, this negative 5x, combining it with each of the terms. Negative 5x times 4x squared is going to be negative 20x cubed. Then negative 5x times negative 6x is a positive 30x squared. And then negative 5x times negative 2 is a positive 10x. And then finally, my last term in my first trinomial combined with all the terms in my second trinomial, negative 1 times 4x squared is a negative 4x squared. Negative 1 times negative 6x is a positive 6x, and negative 1 times negative 2 is a positive 2. My last and final step is just to combine those like terms, which, starting with our highest degree, there's no other x to the fourth, so we're going to have negative 16x to the fourth out in front. We'll then move on to our x cubed, which I have a 24x cubed, and I'm subtracting a 20x cubed, so that's going to be a positive 4x cubed. Then we'll move on to our x squareds, where I have an 8x squared plus the 30x squared, which is the 38x squared, but then I'm subtracting a 4x squared, so that's going to be a positive 34x squared. Then I have a 10x and a 6x. Those can be combined together to give me 16x. And then lastly, my lone constant of 2. So negative 16x to the fourth plus 4x cubed plus 34x squared plus 16x plus 2. That's my solution for number 20. Number 21, again, we're going to have a lot of work because we're multiplying together two trinomials. But that'll be okay. Let's just try to keep track of the signs and then combine those terms together. So starting with the first term in our first trinomial, we need to combine it with every single term in our second trinomial. So x squared times negative x squared is going to be a negative x to the 2 plus 2, so x to the 4th. X squared times a positive 3x is going to be 3x to the 3. 3x cubed, since I have a degree of 2, multiplied by a degree of 1, that's a degree of 3. Then x squared times negative 5 is negative 5x squared. So that took care of our first term. Moving on to our second term, that negative 2x, combining that with negative x squared is a positive 2x to the 3rd. Negative 2x combined with 3x is going to be a negative 6x squared. And then negative 2x combined with negative 5 is going to be a positive 10x. Now on to my last term that I'm going to be distributing through. Negative 8 times negative x squared is a positive 8x squared. Negative 8 times 3x is a negative 24x. And then negative 8 times negative 5 is a positive 40. Finally, we're going to simplify this down. You can see that we only have one term with an x to the 4th, and that's our highest degree, so we have a negative x to the 4th. Combining my x cubes, I have a 3x cubed and a 2x cubed. So that's going to be a 5x cubed. Then I'll move on to my x squareds, where I have a negative 5x squared, a negative 6x squared, and an 8x squared. Negative 5 minus 6 plus 8 is going to be a negative 3. So that's going to result in a negative 3x squared. So subtracting that 3x squared. Then I have a degree of 1, which is 10x, and another degree of 1, which is negative 24x, which is going to result in negative 14x. And last but not least, my constant of 40. And there we have it. Negative x to the 4th plus 5x cubed minus 3x squared minus 14x plus 40. Moving on to number 22, I'm back with binomials, so a few less steps than multiplying those trinomials together. Starting with my first term, distributing that through, negative 4m times negative 6m is a positive 24m squared. Negative 4m times a negative 6n is going to be a positive 24mn. Then, finally, negative 4n combined with each of those terms, we have negative 4n times negative 6m is a positive 24nm, or mn. Remember, the order doesn't matter in which we write it. And then negative 4n times a negative 6n is a positive 24n squared. And you can see here that we have an mn and an mn, both to a degree of 1, which can be combined. So we have 24m squared plus, combining those two terms, 48mn plus 24n squared. That's our solution for number 22. And number 23, again, just combining two binomials together through multiplication. First, outside, inside, last. 8u times 6u is 48u squared. 8u times 6v is going to be plus a 48uv. Then 4v times 6u is going to be plus a 24vu, or uv. Again, since we're multiplying, the order doesn't matter. And then finally, 4v times 6v is a 24v squared. And again, what I mean when I said that since we're multiplying, order doesn't matter, this 24 times u times v is the same as 24 times v times u. The order in which we write the variables doesn't matter. I wrote them this way to make it easier to see that I already have a like term. So I'm going to have 48u squared plus, combining those like terms, 48 plus 24 is going to be a 72, and that's a 72uv plus a 24v squared. That's my solution for number 23. Now, finally, moving on to our critical thinking questions. let's dive into number 24, where all we're going to do is simplify. This says to simplify a plus b times c plus d. So again, we're foiling, distributing through. First, outside, inside, last. That's what I mean by FOIL. First, outside, inside, last. Just a fun acronym to help you remember how to distribute binomials. But again, we're just combining each term of one polynomial with all the terms of the other. So we have a times c plus a times d plus b times c plus b times d. And none of these terms can be combined together, so there we go. This is simplified. Expanded out, AC plus AD plus BC plus BD. A last and final problem on this worksheet, number 25. We're going to simplify and then classify by degree and number of terms. So, let's get started. Simplifying this, we have, well, let's look at this. We have a monomial that's added to a monomial multiplied by a binomial. Order of operations matters. So we need to multiply these two first before we add this term, because multiplication comes before addition. And since there's no way to simplify down what's in the parentheses, we're going to need to distribute through when we multiply. So we're going to have 2x, and we're going to add that to 3x squared times 4x, which is 12x to the 3, because this is an x to the first. X squared times x to the first is x cubed. And then we're going to subtract 3x squared times 5. Or add 3x squared times negative 5, however you want to look at it. But that's going to be a 15x squared that's subtracted. Now we're going to combine any like terms and rewrite with the higher degree towards the front and then the other exponents in descending order. So we can't combine any of our terms because we have a degree of 1, 3, and 2. So starting with that degree of 3, we're going to have 12x cubed minus our next degree of 2, 15x squared, plus our degree of 1, 2x. And what we have here is our polynomial, but we need to classify it by both degree and number of terms. Well, the highest degree is that degree of 3, so we know that it's cubic. And what else? It has 3 terms. So we know that this polynomial is a trinomial. So it's a cubic trinomial. And that's our last and final solution on this worksheet. If you have any questions, please feel free to leave them in the comments below, and I or one of your peers will get back to you as soon as we can. As always, to show your support, don't forget to like, subscribe, and share. Happy learning!